Hello and welcome to Insight Ophthalmology. This is Dr. Amrit welcoming you to the Squint series. Today we are studying how do we go about measuring the deviation. Now in our previous videos we explained to you how do we go about detection of the squint, and in this we shall be discussing about the various tests that help us in measurement of the squint or the deviation. So enumerating these tests broadly, these tests are the ones that use corneal reflection, or they can use the redressal eye movement, which is example is the prism cover test, and of course there are a lot of other tests as well. So there are certain important aspects that you need to keep in your mind while you're actually trying to measure the deviation during these tests. So make sure that you know what is the level of dissociation that you are inducing in the patient while carrying out the test. Is proximal convergence also being induced while you are testing the patient? Is the distance at which you are measuring the squint fixed, or is it getting variable? And is the accommodation controlled? Does the test require simultaneous perception and normal retinal correspondence in order to give you an accurate subjective response? And is central or near central fixation necessary for the test, or could you actually carry out the test even if the central fixation is not present? So, all these important aspects are something that you need to keep in your mind. So what would be an ideal test to measure the deviation? An ideal test would be that you can carry out in free space with maximum dissociation, and the distance at which you are carrying out the test should be fixed. So if you are choosing to measure the deviation at 33 centimeters, throughout the test the distance should be 33 centimeters. If you are trying to measure the deviation at some distance, say at far, then also the distance should be controlled. Similarly, the accommodation. Make sure that you control the accommodation of the patient and keep it stable throughout your test. This can be ensured by giving him a nice accommodative target. Okay, a normal pen light torch, if you use for your measurements of squint at near fixation, that's going to cause variable amount of accommodation. So therefore, it's very important to use a proper accommodative target. So now let us go back to the slide. Test using the corneal reflection, test using the redressal movement, and other tests. And now we are going to enumerate the various tests that come under each category. So what are the tests that come under the corneal reflection test? So these are your Hirschberg's corneal reflex test, the Bruckner's test, and the prism reflection test, which is also called the Krimsky test. Now, for the sake of simplicity, we shall be restricting this video on these three tests basically. However, let us also enumerate the various tests that uses the eye redressal movement. These are the ones that use the prisms, like prism cover test and the prism bar cover test. So if you're just using the loose prisms, it is called prism cover test, and if you happen to use these prism bars, it is called a prism bar cover test. Then of course there are variants of prism cover test, which is called simultaneous prism cover test, and there is a role of occlusion in prism cover test as well, which we shall be discussing in the next video. What about the other measurement tools or other measuring tests? These are the ones that use an amblyoscope. Then we can measure the squint using a Maddox rod. We can also use a Maddox wing. We can use charting like Hess charting and the Lee's scale. Now let us talk about measuring the deviation using the corneal reflection and the various tests that were underneath that. So the first test is the Hirschberg's corneal reflex. Now I already explained to you in the first video on squint series, that is phoreas versus tropias, in which I told you where exactly the corneal reflex will be centered in the eye in each type of deviation. So in esodiviation, the corneal reflex will be slightly temporal. In exodeviation, it is going to be nasal. And in case of your hypodeviation, the reflex is shifted upwards, and hyperdeviation, the reflex is shifted downwards. And I told you in that video also how approximately you can actually measure the amount of deviation using the Hirschberg's corneal reflex test, right? So this is an explanation that is given in the textbook von Nuden. So here you can see that when the corneal reflex is present exactly in the center of the pupil, the patient is said to have no squint. However, if the reflex is present at the margin of the pupil, and in this case because it is located on the temporal margin of the pupil, it means that we are dealing with an esotropia and the measurement here will be 15 degrees, right? So at the margin of pupil it is 15 degrees, then if it is near the limbus, it is 30 degrees, and if it crosses the limbus, it is 45 degrees and more than 45 degrees, right? So this is an approximate measurement that you can find using the Hirschberg's corneal reflex, and this is according to the textbook of von Nudel. However, if someone asks you about the exact measurement values, so you can tell them that every 1 mm of displacement of the corneal light reflex from its central position is estimated to represent about 7 degrees on a round globe, and that is equal to about 15 prism diopters of deviation, right? So if you would see carefully here, the denotion, we are actually denoting the measurement in degrees, right? So at the pupillary margin it is 15 degrees, at the limbus it is 30 degrees, and beyond the limbus it is 45 degrees. Now if you were to actually convert these degrees into the prism diopters, okay, you have to multiply it with 2. Okay, so 1 degree is roughly equal to 2 prism diopters. So a person who has 15 degrees esotropia, in prism diopters it will become 30 prism diopters of esotropia. Okay, the one who has 30 degrees of esotropia will have 30 into 2, so that becomes 60 prism diopters of esotropia. Similarly, you have to multiply 45 with 2 and so on, right? So every in millimeters, 1 millimeter displacement is equal to 7 degrees of uh, 7 degrees of the deviation, and that in prism diopters is about 15 prism diopters. So I hope that is clear. Okay, now coming to your second test, that is the Bruckner's test. Okay, now the Bruckner's test is basically a test in which we are using a direct ophthalmoscope, and we are actually projecting the light through the direct ophthalmoscope through the dilated pupil of both the eyes, and what we are observing is the reflex that is going to come from your fundus, right? So in a way it is basically a trans illumination test. Okay, so we look through the ophthalmoscope and the examiner is going to see the patient pupil shining red in color, and the red light is actually coming from the light which is reflected by the choroid and the retinal surface. Basically it is the internal limiting membrane that is actually reflecting the light. Now if a patient has central fixation, okay, the fundus red reflex that comes will come basically from the fovea. Okay, so if you have a person who has central fixation and who's looking straight forward, that means the image is being formed at the fovea, right? So it means that the red reflex that is coming, that is from the fovea. So this is a very important point. I will tell you why. Now what happens is that normally we know that the fovea actually has the slanting slope. Okay, so parafoveal region has a slanting slope, and of course fovea here this is the foveal pit, right? Now if the light is actually projected onto a straight surface, it is going to get reflected in the similar manner. Okay, so it's going to go straight in and come out straight, right? So if you were to have a look at such a straight uh, projection of rays, you are going to see a very bright reflex coming out from the patient. So suppose the light was being thrown onto the surface of retina. What is happening with the light that the examiner is throwing using an ophthalmoscope is getting reflected from a flat surface or a straight surface, and therefore all these straight lines are going to enter the examiner's eye, and therefore we are going to see a bright reflex, right? However, now when the person is actually fixating, okay, the fovea comes in the center, and what happens is the fovea actually has a slanting surface. So when the light falls on this slanting slope of the fovea, it gets reflected in different directions, and it is not reflected straight back to the examiner, and therefore obviously the reflex that you're going to see is also going to be a much dimmer reflex. Okay, now if a patient has some sort of squint, what happens is that one eye would be looking straight forward and one eye is going to have squint, right? That means the visual direction of that eye will be different from the normal eye, right? So the eye which is normal is going to form the image of the ophthalmoscope or the reflex is going to come from the fovea. And what did I tell you? The reflex which is coming from the fovea is going to be much, much dimmer compared to that which is coming from a parafoveal or a peripheral retina. Now, in the eye which has strabismus, what happens is that the image is not formed at the fovea, right? And therefore the light rays which are going inside the eye, they are also getting reflected from the parafoveal or from the peripheral parts of the retina, and therefore it is going to form these straight rays of reflected light, and therefore the reflex is going to be much more brighter. So that is a very important point regarding the physiology of the Bruckner's reflex. So what happens in Bruckner's test is that whenever there's a central fixation, or whenever in a normal eye, what happens is the reflex is going to be darker, whereas whenever there's a misalignment of one eye, the light will now reflect from the parafoveal retinal surface, okay, and these light rays will be perpendicular to the direction of the incoming light. This leads to a coaxial reflection, and therefore the brightness of the fundus reflex. So this helps you in detecting strabismus and anisometropia. When there's strabismus, there will be misalignment, and therefore when you're actually going to compare the red reflexes in both the eyes, there will be an asymmetry of the red reflex, and that is an important principle of Bruckner's test. So Bruckner's test, you take your ophthalmoscope, you shine it into the patient's eye and compare the symmetry of the red reflex. The eye that has misalignment or that has anisometropia will basically show you a much more brighter fundus reflex compared to the normal eye. So it can act as a screening test for strabismus and anisometropia. Now, this test can be actually very useful in uncooperative children when the examiner is more adept in doing an ophthalmoscopy rather than actually doing a cover test. Okay, however, below the age of 8 months, it is slightly difficult to do this test because the foveal development is actually, it gets completed by 8 months of age. So before that, if you see any sort of asymmetry, it could actually be because of the asymmetrical development of the retina as well, right? So this test is not so reliable, and also sometimes it can also give you false positive results. So here, as you can see in the first picture, the child, just by the look of it, you can actually make out the child is actually having esotropia in his left eye. And also you can see that the reflex seems to be much more brighter from the left eye compared to the reflex that's coming from the right eye. So that indicates that the left eye is actually the problematic eye. Okay, now similar in the second picture, which one is the brighter reflex? It is the left eye reflex which is brighter compared to the right eye. That means the right eye is actually showing you the central fixation, it's a normal eye, whereas the left eye is a strabismic, or the eye which is deviated. So I hope that is clear regarding the Bruckner's test. Now in the first image here, you can see that the reflexes that are coming from both the eyes, they seem to be of equal brightness. So this means that the Bruckner's test is negative. However, in the second picture, you can see that the reflex which is coming from the left eye is more brighter compared to the right eye. That means there is a asymmetry in the red reflexes of both the eyes, and therefore in this case we say that the Bruckner's test is positive. Now let us go to the test which is the Krimsky's test, also called the prism reflection test. So the scientists who developed this test originally named the test as the prism reflection test because you're using a prism and you're using the reflection of the light from the cornea. So here you're using the corneal reflection, okay, and because the scientist was Krimsky, it is also called a Krimsky's test. So the prism reflection test or Krimsky test, basically, you ask the patient to fixate on a spotlight at near. Okay, so this is a very important point, that this Krimsky test is done at a distance of about 33 centimeters, right? So it is carried out at a near distance. Then we are going to use a prism, either a loose prism or a prism bar, and that is going to be placed in front of the fixing eye with the apex of the prism in the direction of the deviation. So this is a very important point. This is how the test was actually described originally by Krimsky, that the prism has to be placed in front of the normal eye, the fixing eye, and not in front of the deviated or the squinting eye. So for example, in this case, you can see that the left eye is a squinting eye and the right eye is the normal central fixing eye, and therefore the prism is going to be placed in front of the right eye. Now, the second thing is, how are you going to place the prism? The prism is going to be placed in such a way that the apex of the prism will be in the direction of deviation. So here, the deviation is esotropia. Esotropia means that the eye is deviated inwards, and therefore you are going to place the prism in such a way that the apex comes inwards. Okay, so this is how you're going to place the prism. So apex is coming inwards towards the nose and base is outwards, and this position of the prism is called a base out prism. Okay, so in esotropia, the prism is placed with base out. So I hope that is clear. Now let me explain that same concept a little bit more in detail. So in esotropia, what is happening? The eye is deviated inwards, and therefore you're going to place the prism in such a way that the apex is also inwards, and you're going to place it in front of the fixing eye, right? So this is how you place it, and this placement is called a base out placement because the base is outwards or temporally. What about exotropia? In exotropia, the eye is deviated outwards, and therefore the apex also has to be towards the outer side, and this is how you're going to place the prism. And where is the base? The base is inwards, and therefore in exotropia the prism is placed in a base in fashion. What about hypertropia? In hypertropia, the eye is deviated upwards. So where will be the apex? The apex is going to be placed upwards, the base will be downwards, and therefore it is called a base down position. In hypotropia, the deviation is downwards, and therefore the apex will be downward and the base will be up, and this placement is called a base up placement, right? So just remember this. The Krimsky test has to be carried out at near. It has to be carried out with the prism placed in front of the fixing eye, and the position has to be in such a way that the apex is towards the deviation. Now here in brief, let me tell you about the prisms. So a prism has an apex and it has a base, and the light, when it passes through one surface of the prism, it always gets reflected towards the base, right? So light ray which is passing through the prism, it will bend the light towards the base. Okay, however, the image is displaced towards the apex. Okay, so although the light is getting bended towards the base, if you were to actually observe through the prism, you will feel as if the image has been displaced towards the apex of the prism. So that is a very, very important point. Light bends towards the base and the image gets shifted towards the apex. Now, what is the optical principle behind this Krimsky test? Okay. Now, in Krimsky's test, as I told you that you're going to place the prism in such a way that the apex is going to be towards the direction of deviation. So, for example, here, if the left eye has, say, esotropia, we're going to place the prism in such a way that the apex is towards the deviation and the base is outwards. This is called a base out position. So, what happens if you see through the prism? The patient is going to feel as if the image of this object is shifted towards this apex, and therefore the eye is going to turn inwards towards the apex. Now, if the left eye is going to turn inwards, the right eye is also going to make a conjugate movement that will be towards outside. Okay, and this happens because of your Hering's law. Okay, so that is basically your optical principle. So the eye behind the prism is going to move in order to maintain fixation, and because of your Hering law, the eye which was squinting, that is also going to make a conjugate movement. For example, here the left eye has an esotropia. You place a prism in front of the right eye, which is the fixing eye. The image will be displaced towards the apex, so the right eye is going to move towards the left side, and conjugately, because of the Hering's law, the left eye is also going to move towards the left side. Okay, and at one position, what happens is that as you keep on increasing the prism strength, okay, what happens at one particular point, the reflection of both the eyes are going to match. That means the reflection is now going to become centered in both the pupil, and at that point you are going to note down the value of the prism, and that is your measurement of the deviation using the Krimsky's test. So I hope that is clear. Okay, so it is one important point is that the examiner has to be seated directly in front of the deviating eye. This is specifically important because you don't want any false reading caused by the parallax error, because you're actually observing, you are actually trying to observe the reflections both in the through the prism and without the prism. So it's important that you sit in front of the deviating eye and then look at both the reflections, right? So similarly here the patient actually has esotropia. You can see the reflection here is present at the limbus, and in the second picture you can see we have introduced a base out prism, and so the reflection has slightly moved towards the pupil, but it is still not in the center of the pupil. So now we increase the strength of the prism still remains to be placed as base out prism, and now you can see that the reflexes are centered within the two pupils. The reflexes are present at the exact spot in the two pupil, and now this is your deviation, right? So this is your measurement of the deviation. So this is your Krimsky's test. This is how it is done. Now, what about modified Krimsky test? Now, in sometimes what will happen is that there will be a mechanical limitation in the deviating eye. So, in such a condition, that conjugate movement which was occurring because of the Hering's law will not occur if you do a normal Krimsky test. So, in such a case, what you can do is you can actually place your prism in front of the deviating eye instead of putting it in front of the fixing eye, right? So this is called a modified Krimsky test. However, observation of the corneal reflex at the center behind the prism is much more difficult, and therefore the Krimsky test is the preferable test to do. Now there's a controversy here regarding the Krimsky and the modified Krimsky test. Most of your standard squint textbooks and also the original test which was done by Krimsky, it tells you that the Krimsky test is basically called the prism reflection test, and in Krimsky test you place the prism in front of the fixating eye, whereas the modified Krimsky is the prism is placed in front of the deviating eye. However, there are a lot of books, and even the American Academy of Ophthalmology in its latest edition also, it says otherwise. It says that in modified Krimsky the prism is actually placed in front of the fixating eye. So that is one controversy that you should be aware of. So what are some of the drawbacks of this prism reflection test or the Krimsky test? Now the first thing is that it is definitely not as precise as the prism cover test, okay, and that is what we are going to study in the next video. Then moreover you are carrying it out at a near distance, so deviation at distance fixation is very difficult to measure during with this test, and specifically because the examiner is going to sit in front of the deviating eye. Accommodation also cannot be controlled. Why? Because we are using a pen light. We are not using any accommodative target to carry out the Krimsky test. Okay. The angle kappa, because the angle kappa we know we usually see it in the form of reflection. So the angle kappa is also included in the measurement. So the Krimsky test might not be so accurate as well compared to the prism test. And of course, two observers can actually observe the corneal reflection at different positions. So there always going to be some inter-observer variability. So the question is, if there are so many drawbacks, when do you actually use this Krimsky's test? So it is used as an approximate measurement of the angle of strabismus, specifically in patients who are too young to cooperate with your prism test and the cover test, right? And sometimes patients will have this poor visual acuity, which will not allow them to have a good amount of fixation or good amount of accommodation on the accommodative target. So in those cases, you can go ahead and do an approximate measurement using these Krimsky's tests. So I hope that is clear. Now, this table over here is very important. It's a table which tells you regarding the comparison of the various tests that we are going to use to measure strabismus. Now here in this video, we have discussed about the tests that uses the corneal reflections to measure the squint. So the question is, can these tests, that means the Hirschberg's test and the Bruckner's and also the Krimsky's test, can you do it if the patient has reduced visual acuity? The answer is yes. Can you do it if the patient has limited cooperation? Yes, it is an indication to measure the deviation in children who are not very cooperative to your cover test. Is simultaneous perception required for this test? No. Can it be done in 9 positions, or are you supposed to do it in all the 9 positions of gazes? The answer is no. Obviously, because we're doing it only in the primary position of gaze. Can you measure torsion using these corneal reflection? The answer is no. Okay, so we're going to go ahead with other kind of tests also in our further videos. That's all for today. I hope you enjoyed it. Thank you and have a nice day.